all those are wrong. So you might want, don't throw that away. We'll go over it. What we'll do is we'll correct it. What would be the right way to do it? Okay? So you can see that. Well, we're going to finish up with limits, differentiability, and continuity today, and we'll do some problems. And if we get to go a little further than that, that's great. I'm behind schedule. We should have gotten through F prime. So I gave you the notes, and yesterday we got through the first page and most of the second page. And make sure when you do horizontal asymptotes that you look at x going to positive infinity and negative infinity. Now there are 2 videos going up. I'm videoing both my sections. So we're a little bit behind in my period 2 class, but that's okay. But so you can look at either one. They'd be slightly different. Okay, we're going to do continuity next. We did limits yesterday.
We learned a cool trick.
Oh, yeah, we did L'Hopital's rule. Okay, continuity, that actually has been a direct question on the exam, I think 2011, and I know 2012, and we will do the 2012. I tend to work backwards, go 2012, 11, 10, because the exam's going to be more similar to the more recent exams than the older exams, because they have changed it, and I've been in this since 91, so I've seen those changes. Okay. If we have a continuous function, now if you're in multiple choice, you don't really have to worry about justifying your answer. You know that you're not going to lift up your pencil. If you have to lift your pencil up to trace the function, it's not continuous. I mean, you know that. But mathematically, you remember what we had to have? There were 3 conditions, and these are what you have to state on the free response part. Yeah, you have to have this on the free response to get your points. But it's not that bad if you remember it. If I want a function to be continuous at some value, c, f of c exists. Because how can a function be continuous if there's a break in the graph? So if this is my situation, that's not continuous at c because there's a break in the graph. So you can't have any breaks in the graph. What else has to be true? What about this situation? Well, but how do you say it mathematically? What's the problem with this in terms of limits?
Oh, the limit from the left is not equal.
The limit doesn't exist because the limit from the left is not equal to the limit from the right. So the limit as x approaches c of f of x exists. In fact, let's even write that down because that's exactly what they're going to look for. In 2012, I know they did. So they're looking for the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right. And we did that yesterday. For a limit to exist, the left has to equal the right side. They're in particular going to look at you looking for these limits. You have to write that. You have to be clear about what you're trying to do. 500,000 exams. Okay, so we can't assume anything, even though I might be looking at it and I'd say, well, yeah, I really know what they mean. It doesn't matter. I can't do it. Okay, and what's the third thing? Does this limit exist on this example right up here? Yes. The limit from the left, limit from the right. Remember, what is a limit? It's just the y value. What's the y coordinate getting close to? What's wrong with this? Why is that still not continuous? What if I do this? F of c exists everywhere, but it's not continuous. What has to be true to make this continuous? This has to be right there. Mathematically, how do you write it? The limit has to exist, and not only does the limit have to exist, it has to equal the value of the function there. So when I hit on something during these review sessions like this, that's important. You're going to have to know that. I'm not going to get into all the details. It took us all year to get through all the details. And hopefully they support everything we did. But that's one you're going to see, because I grade the exam. So I'm not going to hit on the limit laws too much because you use them automatically. You distribute your limits. That's all this is doing. Yeah, it's hard to read on that one. I have to find my original. So you can distribute limits over division, addition, subtraction, even multiplication. You cannot distribute a derivative over multiplication, unfortunately. You have to use the product rule. And integrals are even worse. They don't distribute, but the limits do. Okay, so I'm going to turn the page. And basically, the substitution theorem says we always substitute in the value of c. But I've already said that, so why say it again? So this is a little redundant here. The squeeze theorem, you're not going to have to use it to prove anything, I don't believe. But no. In the old days, yes. I believe we did, but it makes sense. So let's look at the squeeze theorem. It is at the bottom of the page, theorem C, the squeeze theorem. Now, it's just going to make sense to you. I don't think you're ever going to have to use it to prove anything. But I have three functions. I have f of x. I have g of x. And what's going to happen is that some particular c value, these guys are going to be the same. So in some neighborhood, these are going to be the same. So that the limit as x approaches c of f of x equals the limit as x approaches c of g of x. And if I introduce a third function, call it h, and I don't care what happens if I'm not in the neighborhood, so h could do this, but h is trapped between f and g, what do you think the limit of that one is? If h is between f and g, then the limit as x approaches c of h equals what? Equals the limit of these guys. These have the same value. F and G have the same value here, and H is between those. Well, doesn't the limit have to be the same then? Another way to describe this is the sandwich theorem. Depends on what book you use. So all you would have to do is just recognize that something's caught between it, and you'd see that the limit is. So it's equal to the, I'm just going to put an arrow there to save a little time. So it's equal to the limit of those two things. You're not going to be doing a proof. I don't even think in BC they'll do a proof. So that kind of makes sense. At least it makes sense to me. It's trapped in there. Okay, what functions are continuous? Next page. Right here. What functions are continuous? If you get to draw the function and you don't lift your pencil, it's continuous. Well, you know sine and cosine. You know, the sine's just that wave. Same as the cosine. You know they're continuous. All of these are continuous. Even the inverse trig functions are continuous in their domains. Log functions are continuous. The only problem with rational functions, the rational function is one that has a fraction. So if f of x equals 1 over x, that is not continuous where? At x equals 0. Because you can't divide by 0. Okay, guys? But this is continuous everywhere else. So this is a rational function. It's a fraction. And it's continuous everywhere except when you're at a point that's not in the domain. X can't be 0. It's not in the domain. What are polynomial functions? Do you guys remember what polynomials look like? We've been talking about them all year. X squared, x cubed, all those are polynomials. In general, it's x to the n, and n must be what kind of a number? It has to be positive. Can it be a fraction? No. So it's a whole number. So if you have a negative exponent, that is not a polynomial. Polynomials have nice behaviors. Unfortunately, the behaviors associated with the polynomials is not necessarily what works for the exponentials or the logs. So you've got to recognize the difference in your functions, especially if you take the limits as x goes to infinity. Okay, differentiable. What does that mean? Half the year was differentiable. You can find the what? Find the derivative. Now, they will ask a direct question on the multiple choice on this. And so you need to know these next three things. When can you not find a derivative? Derivatives do not exist where? corners, sharp corners. And that's because a derivative really is a limit. So if you take the absolute value function, for instance, and you look at the slope here, the slope is -1. That's the derivative. The slope on the right is +1. These have to come together nicely. So for this derivative to exist, basically the derivative has to be 0, if you think about it. And this is like going backwards in your car, and while you're still moving, shift into forward. That's a very bad thing to do. So you can't have that. So you can't have a derivative existing at sharp corners. So basically it's saying f prime from the left has to equal f prime from the right. Okay? That's important. I don't know if it's in my notes, but if it isn't, put it in there because it's important. Because we're going to do a couple of problems that require us to do that. Where else? What if you have a break in the graph? Can you find a derivative there? No. So discontinuities. So actually, when you know something is differentiable, then you know it must be continuous. So the symbol is this, which is implies. This is a language. Math is a language. So if you know something's differentiable, you know it's continuous. And both of those conditions can be used to write equations to solve for things you're looking for.
So it can be continuous, but not different.
It could be, and here's an example of continuous but not differentiable. So it's a theorem, it does not reverse, unfortunately. And the other one that everybody forgets is the vertical tangents. And they'll probably give you a diagram, and they'll say it's a vertical tangent, and they'll say, which points is this function differentiable? I mean, I've seen the question on the multiple choice part of the exam. And they don't release the exam, but every 5 years, so that they can reuse questions. It may be changed a little bit, but you will see, if you really do the multiple choice exam, you will see those common problems be reflected throughout all those exams. This is one of them. So here's an example of a vertical tangent, but they'll tell you it's vertical. You don't have to assume anything, okay? They will tell you. Now, I don't think I saw it on the 2008 exam, but it's on the 2003 exam. At least I didn't find it. Okay. So we've covered most of that. We'll do a derivative later, and it would have been nice to get through all the rest of this, but we're not going to. You can read through this, though. The notes should be fairly good. Let's do some problems. Now we're going to come back into the multiple choice. Non-calculator, 2008. Now, one of the problems, non-calculator, is if you know the first you have to know the concepts. If you don't know the concepts, you're not going to be able to know what to do. But then you have to figure out what's being asked. If I told you it was a first derivative test, you could do it. So we're going to find, we did number 6. We could come back and do it again if you want, but we did do it. And we did number 19. We're in the multiple choice non-calculator, 2008. So we did 19. Let's see if there's anything more in this one. I don't remember. And number 22 about the rumor, that one has been there year after year in some form or another. Oh, number 25. That's a nice one. So this is number 25 in 2008. I'm going to copy it while you find it. 2008 multiple choice. So you should get yourself organized. Get a notebook, a loose leaf notebook. Non-calculator. You had it from the first day. Monday. Were you here Monday? Then you should have it. I have some extras. Yes? I have them all out. You should have yours from the very first day. Anybody else? I have extras. I don't have a lot of extras. Okay, I forgot what the question is. I copied it. This is really a strong statement. F is differentiable at x equals 2. And I want to find C plus D. So if you don't have your packet, there's the problem. Well, when I know, we'll look in the multiple choice packet. I'll tell you, I don't know. Yeah, it's the same every year. Okay, my function is differentiable at x equals 2. Well, that tells me something. If a function is differentiable, then what's true about the derivative? If it's differentiable, the derivative exists, and f prime from the left has to equal f prime from the right. Okay, now this is multiple choice, so we wouldn't have to be too particular about how we showed our work here. I'm going to do it correctly, but here's f prime of x. This is a piecewise function expected, and this is x less than or equal to 2 and x greater than 2. So if the derivative from the left equals the derivative from the right, what is the derivative from the left? I'm going to use this formula.
2x.
No. The left of 2.
Oh, left.
To the left of 2, that's just going to be c, isn't it? To the right of 2 is going to be what? 2x minus c. Now, if the derivative from the left has to equal the derivative from the right at 2, then c has to equal 2x minus c when x is 2. Does that make sense?
Yeah.
At 2, these two derivatives must be the same. I'm looking to find an equation so I can figure out what c and d are. Well, differentiable tells me a lot. It means the derivative of the left side of this one equals the right side. So c equals 2 times 2, because I want to have it match at 2. That's right. C is equal to 2 because I get c equals 4 minus c. Add c to both sides. So 2c equals 4, and c equals 2. Okay, girls? No. I don't know what d is. We got to find another relationship. Used up one. Yeah, but we know it's differentiable. So what does that mean? If it's differentiable, it must also be. Can there be a break in the graph? No. F is continuous. So I would, there are things to study the last minute just to review. That's one thing. If you have a differentiable function, you have a continuous function, which means that the limit from the left of my function has to equal the limit from the right, which also has to equal f of 2. That's the true continuity if I want everything there. Okay, so what is the limit of this from the left? So the limit, should I write it out properly, as x approaches 2 left? Which formula again am I going to use? I got 2. Which formula will I use? I want to come in from the left. That's this one. Cx plus d. And what's the limit from the right? I'm going to have to slide my board. Hang on. You guys should be doing it with me, not just watching. Which formula do I use from the right? I'm listening to make sure I'm checking for understanding.
X squared plus c. No, I see.
Question. I will. Because it said it was continuous. So if this is a free response, all this stuff I'm doing, you'd have to write out. We'll do 2012. You would have to, no, you were given it's continuous, so I'm going to get an equation here. So first I took the derivative and set the two derivatives equal. Now I'm going to set the two limits equal. Because I need to figure out what D is. I got C. Yeah, that's what this is. That's what this limit is. Let's do it. This is x squared minus cx. because that's what it is. The limits are equal. That's what you're doing mathematically. You're finding the limit from the left when x approaches 2, and these must be the same. So what are you going to do with 2? Just substitute it in. Do you have the right limit? If it's free response, yes. If it's multiple choice, you don't. So 2c plus d equals 2 squared minus c times 2. That's what you want me to do, correct? Mathematically, it's a limit. Okay, so 2c plus d, and you know what c is, don't we? 4 minus 2c, and c was 2, so let's put that in. So this wasn't too bad. They could have given you a system of equations, which would have been harder to solve, but they didn't. So it's 2 times 2 plus d equals 4 minus 2 times 2. So 4 plus d equals 0. What's d equal to? -4. Be careful with your answers. They love these distractors. Answer to A is -4. That's not the question. What's the question? C plus D, which is 2 plus a -4. So the answer is -2. Guess what one of the other distractors are? B is -2, which is correct. I'm not sure where they get C for 0, but what about D? That's 2. You know, they really could have been meaner and put the 2 for C and really gotten you confused. But that's what you do. Now, if this were free response, I'd have to say all that stuff, but it's not. So once you realize that this is what you have to do, that's fine. Now, let's do the calculator part. No, that's not the right one. We're going to go to the calculator one now. Yes. You got that on Tuesday. I got them right here. If you don't have them, I got them. Okay. Let's look at 77. Now, the calculator part starts with 76. Doesn't start at 29 or whatever. 2008. I got to draw the picture. You go ahead and read the question. It's a calculator version. And you can tell because the number's 77. Now, I'm going to make up some numbers here so we have something to talk about. This is 2008 calculator part. Yes, they're different packets. So what will happen is you'll start, I think, with the non-calculator part. Then you put it away, and then you can get your calculators out. So it takes some time to do all this. You probably should put them in numerical order. I gave them to you in numerical order. This is from Tuesday. I have more right here. If you were here Tuesday, you should have this one. On the multiple choice or the free response? No, this is calculator. You can tell because it starts with 77. Well, it's all the same color. They're over there on the table. There's 4 sections.
I have 3 of the sections. I think this one. What's the 4th section?
Well, there's 3. We only gave you the full exam on 2008. We didn't separate it. But there's 4 sections on the exam. Okay, let's answer that question.
Mr. G, is there like a SAT subject test for this? And would you recommend to take it?
Oh, I believe there is for math, and there's 2 levels.
Would that be good to take? Or?
Depends on where you're going to school. Some schools don't look at it. Okay, you have a multiple choice. And I'm not sure what order it is, but no calculator. That's 1 through 28. And how long do you get for that? They've changed some things. 55 minutes. So how many minutes is that a problem? Well, if it were 56, it would be 2 minutes a problem. Which means that you've got to be fast on some so you can think about others. Okay, then you have the multiple choice with the calculator. And that is 76 through 92. And they give you 50 minutes for this. You have 2008. That we gave you on Wednesday. Okay? Ready? Then, you guys,
We don't have all the multiple choice, do we?
you have all the multiple choice that's been released.
Yeah.
Only
Yeah, but not
4.
for every year, right?
All the ones that have been released. They don't release them every year.
I have to do the same one.
No, check. One might be calculator and one not calculator. Okay, well, you should get the right one. Okay, guys. Now, you have the FRQ with a calculator, and there's 2 problems, and you get 30 minutes. You have to do them all. There's 2 with a calculator. Then there are 4 without a calculator. They changed that. It used to be 3 and 3. And this, you get an hour. And then they weigh this. They have a multiplier here so that these are equal. So now the reason why it takes 4.5 hours is because you have to put your calculator away, get your calculator out. They give you a little break to stretch. So it takes 4.5 hours. I think it's the longest one, partly because it's switching back and forth with the calculator. So that's where it's at. You do all 6 of these. That's worth 54 points. This is worth, I don't know, but there's a multiplier to equalize them.
Why do they do 1 through 28 or 76?
So that you know for sure it's a calculator problem. Everything but period 6. These are weighted. This is weighted so that it's equal. 50-50. They're all equal. Pardon? They're all equal. Your whatever 40 points are all equal, even though the time is different. That doesn't matter. Okay. Ready to do the problem? Count them. I don't know. 76 through 92. I don't know. I don't really care. Okay, guys, let's do this problem. It's not a hard problem. You don't need, Casey, you don't need a calculator on this problem. Now, there's no numbers here. Now, when I give you the free response, I gave you the whole thing. We didn't separate the calculator and non-calculator. We did on the multiple choice. Okay, because it would be too thick of a packet otherwise. Now, does the limit as x approaches 2 from the left side exist, Grace? Does that limit exist? One-sided limits, unless they're getting into too many wiggles or a vertical asymptote or a vertical tangent, it'll exist. So does this exist? What is the value about? I mean, I made up numbers so we could talk about it. Looks like it's 2, right? Remember, what is the limit? It's the y coordinate. So I'm traveling along this road, it's the y value that goes with this point. Looks like it's whatever that number is. I made it up. What about the limit from the right? You're going to travel on this road. And what value is that about? 1. So does the limit exist from the left? True. The right? True. Does the limit exist at 2? Why not? Because the left doesn't equal the right. That's what you would say on the exam if it's an FRQ. So this is false. So you want the choice that has 1 and 2. I don't even look at those choices. I do the problem and then I look. Because it isn't going to do me any good. And did the calculator help me at all? No. The answer is C. Question? Okay. I think that was it on limits. But every single thing that we talk about, there will be at least one question on that.
This was actually. Are these just like the editors or? Yeah.
And 89 and 90 are hard, and so is 92. Okay, let's get out 2012. Okay, free response. And this is number 4. Non-calculator. 1 and 2 are with a calculator. And why do you want to do all these problems? Because when you look at them, they're scary. Aren't they? I look at all those words, I go, this isn't math. It is. And once you've done a lot of problem ones, you're going to say, oh, okay, whatever the new one's going to be, oh, that's just like this one. So problem number 4, and we kind of joked around saying, you shouldn't get your AP credit unless you can get this problem right, because this problem is like a textbook problem. We're going to do part C. I haven't reviewed A or B, but you should be able to do those. But now you need to do the work. Now there's a grid. I don't have mine handy. It tells you what types of problems are on each exam. So if you want to work on all the limits and the continuity and differentiability, you go to that grid, and you find those problems associated with that. All the problems, I have everything from 97 on the website. So you don't have a hard copy for 97, but it's there. Okay. And this is x plus 7. Does anybody know what that graph looks like, f of x? And it says, for S, is G continuous at x equals 3? That's the question. Negative 3, sorry. Use the definition of continuity to explain your answer. Okay, putting this away, we're doing 2012. You can write on the back of something if you don't have your 2012. We're only doing C.
I just organized everything.
And then we'll run out of time after that. No, this is an FRQ.
Oh, okay.
You only have multiple choice for 97, 98, 2003, 2012. Hopefully, they're going to release 2012 this year. No guarantees. It should be because it's every 5 years. Yeah, just had to add a little bit. Well, what are the conditions for continuity? Because this is what they're going to look for. If G is continuous at x equals negative 3, then we have to have G of negative 3 must exist. Right? Somehow you have to communicate this to the reader. Continuity. What else has to be true? Remember, there are 3 parts to this. The limit from the left of negative 3 of G of x has to equal the limit from the right. You have to use correct notation, like I'm doing right now. X approaches 3 from the right of G of x. Think about it. You don't have time to be thinking. You have to know what it means to be continuous. But you can do it. We got a month. You can't do it if you wait for the week before the exam. Won't happen. And the limit, as x approaches negative 3 of G of x, has to equal G of negative 3. This is the definition of continuity.
Yeah, I know. But what problem?
Number 4. 2012, number 4. And I believe there was one in 2011 just like it. And I don't know how students did on it. You can go and look on the College Board website, and there'll be a discussion about that. But if they didn't do well, rest assured you'll see it again. Okay, what is G of negative 3? G of negative 3 is equal to the square root of 25 minus negative 3 squared. So it's the square root of 25 minus 9, which is the square root of 16. Somebody said it was 4. Okay, any problems with that?
No.
Okay, Colin? Casey?
G of 3.
So we got this one. You must say what the limit is from the left. I would write it, the limit, as x approaches 3 from the left, negative 3 from the left. I'm going to use this formula. Yes. This is all about, remember, here's the deal, you guys. Convince the reader. Okay. What is that? We just did it. It's 4. They don't care about this work. They're going to say g of negative 3 equals 4. That's what they're going to look for. What is it from the right? X approaches negative 3 from the right. I'm going to use the other formula, x plus 7. So that's equal to negative 3 plus 7, which is equal to 4. Since the limit exists, it's the same from both sides.
That's what I said.
Yes. So I would then write the limit as x approaches negative 3 of g of x equals g of negative 3. If I want to be very particular, I'd say 4 equals 4. So yes, you have to be real clear on what you're doing here. I didn't grade this one. My guess is that the students were not clear. But I've taught you from day one, this is what you mean by continuity. So that's one of your key things that you got to know. 2012. And then there's a spreadsheet, and I don't know where the spreadsheet is. So you should do 2011. Now I can get a little more content so that you're ready to do more problems. But you need to be doing these problems. Yeah, he's got the spreadsheet. Slope fields. Where is it? No, that's FTC. Oh, limits and continuity. Why is this doing this? Right over here. The B exams we didn't give you. Those are the ones that they take in Europe. But you can go and pick them up. They're online. I have everything online. All the way down to 97. So if you need more practice on that, you can do it. But let's look at 2011, because I'm pretty sure I didn't look in 2010. Sorry. Oh, the snow problem is a really nice one. Number 6, 2011. And by the way, the waste problem, number 5, has been repeated many times. Many times. So let's look at this problem. A. That's it. That's all we're going to do is A. Well, no, we might as well do B as well. Okay, this is 2011, number 6. Generally speaking, 6 is the hardest problem. Here's f of x. FRQs. We don't have FRQs except for multiple choice at 97, 98, and 2003, 2008. This is a non-calculator question. Is it continuous at x equals 0? This is 2011, 6, part A. How do you know? What do you have to do? F of 0. has to exist.
Don't know that. Yeah, you do.
What's f of 0? Yes, we do. Which one are we going to use?
You don't know they don't exist, though. Yeah, you do.
Sure it does. X is less than or equal to 0. F of 0 does exist because of this. If this had been this way, then f of 0 would not exist.
No, they're not equal.
This is less than or equal to. They join up there. You don't like the piecewise graph. What is f of 0? Well, it's 1 minus 2 times the sine of 0. What's the sine of 0? So that's equal to 1. Okay? What else do you have to do? You have to find the limit as x approaches 0 from the left. Well, guess what? That's using the same formula, so I know it's 1. What is it from the right? The limit as x approaches 0 from the right. And you can go and check online with the solution as to how many points. I think this is just 2 points. Whoops, I don't want that function. I want what? What function am I going to use for the right? E to the negative 4x. Put in 0, and you get e to the 0, which is 1. So since the left equals the right, and it exists, I can now claim the third one, that the limit as x approaches 0 of f of x equals, and I would be really clear about that, equals f of 0. I would say that that is 1, and I would say this is 1. Because I think they might ask you this, the limit from the left, I want to make sure I get my points, equals the limit from the right. What do you mean, all right? You guys could do B.
So many papers.
It is. Okay, have a great weekend, you guys.
Wow, we have a lot of papers.
You guys, you need to be working on this. Don't wait.